then. So AI has moved from something, many people were just experimenting, to something that now shaping billions of dollars of infrastructure decisions. So maybe to get us started, let's zoom out a little bit and, like let's start with how would you characterize where we are in the current AI infrastructure today? Because we hear about a lot about the GPU scarcity, we hear a lot about the utilization and efficiency. And tell us a little bit more about how CAS fits into this overall, picture.
Yep. Thank you, Murat. So, and as you said, I'm the president and founder of Cast AI. So we have we're kind of in the front seats of many of those, not just with our customer, but with ourselves, because we use a lot of those agentic framework. We built a few also, and we use them for ourselves too. So we see a lot of things slightly probably before others, not because we're smarter or anything. It's just because we see more of it in our daily life. I'll tell you one thing. The hype is real, but I'll tell you why it's real. GPUs have three things that are incredible. The first one is they're very, very useful. I mean, think about it. If you are a developer, you don't code anymore, right? Some developers still do, but most of others don't, including ourselves. So if you don't code because you use a coding agent that code for you, then if you don't have access to one, you're left behind. So it's existential to you as a human to be able to use coding agents in a almost all-you-can-eat fashion. But now think of this as it's the main business of your company, meaning you produce software for a living. Then suddenly coding agents become existential to your business. And that's just coding agent. Replace the word coding by something else. If you don't do it, someone else will do it, and then you may not survive that revolution if you don't follow it. So they're very useful, and I would even say they're existential for humans or for businesses. Frankly, the same thing now. The second thing is for GPUs, they are really expensive. Murat, you did our Series A. Your job is that, right? You are investing in a lot of companies that use and need GPUs. Today, I'm spending roughly 6 times more in GPU than in my entire cloud bill. And I projected this to go by end of year, we will spend around 20 times more in GPU than in anything else in the cloud.
Because of the agentic workflows.
And because they are expensive at the same time. The third issue with GPUs, they're very hard to find. So, I mean, it's like the perfect storm, right? You have something that you cannot do without. It's existential to you. They're extremely expensive and you cannot find them. That equals hype. That is the hype. We're living this every day. But the problem with hype is a lot of people say, oh, that's a bubble then. No, it's not a bubble because they are useful. It's existential. If you don't have them, your business will suffer from them. That's the world we live in. I'm going to show you one screenshot. I just took it earlier of the token economy and how and where is the token economy going. And you're going to see, I'll promise you, I'll not show a lot of things, but this one, it's not from us. It's do you guys see that screen?
Yeah.
What you see is an estimation by Goldman Sachs. It's recent, right? It was done in May. So estimation by Goldman Sachs of token production or use of token in, I think it's in the world. And we are here, like here, we are here, just here. This is where we are. I don't know if you see my mouse, but we are in mid-2026. So the enterprise agents haven't even taken off in that graph from Goldman Sachs. And then from that thing, which I cannot even read, it's probably less than 10 quadrillion tokens. It's go to higher than 120. Okay, it's hard to predict 5 years in the future, but even if it's already hard to do it in 6 months. But that level of growth in token is what we experience. We double roughly every month-ish ourselves, the amount of token we consume. That is the trajectory of something that is extremely expensive to run, that is impossible to find. You see the hype there, right? And frankly, even if it grows at 1/3 of the speed, it doesn't matter. It's going up at a trajectory that is impossible to comprehend as human. And that because that thing is super useful.
Yeah. Maybe, I mean, I think what makes this conversation is relevant, what you guys do at Cast. Maybe talk a little bit about, you know, how you guys fit into this overall AI infrastructure, right? Because initially, Cast was Kubernetes workload optimization, and you guys expand a lot in the past 3 years. Like, why are you relevant in this current environment? While we talk about this GPU scarcity, token maxing, and all these agentic workflows.
So we have a long history in using machine learning LLM now to solve difficult problems. And the first problem we tackled was, hey, we use all those compute resources in the cloud or on-prem. And the question we were wondering is, do we use them very efficiently? We knew that it wasn't great because my previous startup was a cybersecurity company. We then became part of Oracle. We had this cost on AWS that was completely out of control. Right? We went from a few $1,000 a month to a bit higher than $1 million a month in 3 years, and it was in 2018. There was no tools at the time that would allow you to even understand why you are spending so much. Like AWS would send us a bill of 100-page, the 100-page death of every month. Like you're wondering, what do you do with this? Oh, wait, it's 100 pages. It's 100 PDF pages that you had to print in some form because nobody would analyze it for you. So we felt that let's fix this for once and for all. So we built some automation around it, and we did this for Kubernetes. So we built agents. We didn't use that word because nobody would understand it. So we were saying we built automations. Then we start to use the word autonomous, feeling, oh, people will understand that better than an agent. Or an automation. So we built autonomous agents that you drop inside your cloud account. And from that moment, those agents will spread around and identify all these Kubernetes use. It's called a Kubernetes cluster. So application that use containers. Sometimes you use the word cloud native. That's the same thing. So all these things that use cloud native, you have an agent that goes in, understand what they need, and adjust the compute resources to what those applications really need to run. You do this in real time with this obsession of efficiency, and you get a fantastic result, which is your bill will reduce by 2/3 at least, because as human over provision everything. That's our nature. And so when you use agents that don't have that same emotion, those agents will be obsessed with it and say, well, I'll give you what you need, but nothing much. Nothing too much above it, never below it, otherwise your performance will suffer. So that was the idea. And then so we were using a lot of machine learning techniques, LLM now, to provide very quick answer to what do I need to run and make sure you provision that and do rinse and repeat every second. And suddenly you had an autonomous agent that do what the DevOps engineer would do, except the agent does it in a second when the DevOps engineer may do it 2 or 3 times a month. We don't replace the human. We do things a human can do. That was the idea. About a year ago, we started to notice what some of our customers are using GPUs, a lot of GPUs, like we were, but they were too. We said, well, then we built an agent for managing GPU provisioning. Then we built another one for optimizing GPU use. And so that's where we evolved. We we are now very, very busy deploying to our customer some form of token optimization. So you don't optimize just the cost it runs, but you optimize based on the outcome you want. And based on the outcome you want, you mobilize the infrastructure and all the pieces to provide this outcome. So that's where we went. But not it's a natural extension of when you optimize things, then you make it obsessed for efficiency. You're looking at where your cloud bill is going to, and token optimization is where it's going for some of our customers. But you saw Goldman Sachs, right? That thing that goes up is many, many times bigger than the entire cloud industry today. I would even argue that AWS missed it, and Google missed. Google less. Azure missed it also. They let the neocloud thrive because they missed that market, and now the neocloud took over a lot of those growth. Great for them. And
maybe I'd like to kind of double click on the workflows and workloads because as you kind of talked about, you guys start as a CPU optimization. Now a lot of the work around like GPU virtualization, reducing the provisioning, and how do you make sure companies get the right buck for the money they're paying. What are the analogies when you think about the enterprises today? Because the CPU problem was people were provisioned based on the peak demand, and they didn't care much about the workloads behave, right? Like do you see similar analogy with the GPU, like people over provision based on the peak demand or the forecasted demand because the agentic workflows, incredibly bursty, or there are some nuances in there?
yeah, no, it's worse than you think. When I was saying nobody really, so first nobody understood how to manage compute. That was simple. Managed compute means how many CPUs do I need? Mostly the question is always how many CPUs. Memory comes with it. How many quantity of compute? Like I have a laptop with 4 CPUs. How many of those do I need to run a banking app? It's impossible to answer for the human already. Now you're telling the customer, well, how many of these things that cost 100 times more do you need? And then the users are thinking, well, but wait a minute, I need to think about tokens now because the unit of cost is an abstracted element. So it's not anymore a compute resource. In most of the case, it's a cost per token resource. And now you have to calculate how many tokens you need to budget for an outcome that you don't really get yet because you saw the graph from Goldman Sachs, the agent workflow or the agentic framework in enterprise is just starting. Like the amount was very small in 2026. And that's the one that is taking off in the next few years, right? So I'll show you one more thing. What I'm going to show you is to tell you how much it's very hard to manage it. We had an idea of asking one of our agents, the one that provisioned GPUs, what is the true utilization of GPUs that an enterprise have? So think a very large Fortune 500, they have a bunch of compute and GPUs, CPUs, a lot of things. How much are they using it in percentage? And NVIDIA has there's a very nice way to measure it. And I'm going to show you the number. I'll share my entire screen so you see it.
I have a guess, but let's see what the actual number is.
You already know that's why I showed that to in a conference a few weeks ago. 5% is the number. So this is non-optimized, simple measurement. It's not a survey. It's a measurement. So there's no emotion there. It's a measurement of how much on average those GPUs are used in average enterprise customer. So we are excluding digital native companies there. Think Fortune 500. And this is statistically relevant. So it's not on a small sample. And this is before any sort of optimization. So this really is the raw measurement of when you connect an agent. These are our customers now, but it's when you connect our agent to a cloud account you measure the utilization and you get this number.
Mm-hmm.
It's slightly different by cloud provider, but frankly, it's bad and worse, but it's bad anyway. So it's lower on Azure, higher on GCP. Kind of feel, yeah, GCP has more cloud native companies probably, and Azure is more enterprise. Yeah, probably the enterprise is not as advanced, but then this graph shows mostly enterprises. So I think it's telling that even for super expensive resources that are not very well used, because it's very hard to do it.
What is it? Maybe Laurent, double click on there. What is the actual problem? Is it the scheduling problem? Is it like the architecture of these GPUs talk to each other or wait times through memory? Because ultimately customers paying for per hour, let's say H100s or B200s or whatever that may be, right? You're still, occupied with certain workflow.
Yeah.
It's just the order of things that doesn't really matter. Like what is it that the structure, is there a structural problem here that the utilization is this low? Because this number is ridiculous, right? Like you're talking about scarcity, super expensive, everybody's chasing GPUs and memory, and numbers are very, very low.
I can tell you that after we optimized, it doesn't look at this like this anymore. Our own GPUs are at 99% usually utilization. But I'll give you some ideas because we spend a lot of time thinking, why is it like? By the way, it's great, it's my business, but still, why is it so low? So low?
Yeah.
First, look at the memory utilized. So memory is high, 35%. It's much higher than actually the average use of memory for the traditional cloud industry, which is memory and CPU. On average, memory is used 20% for regular machines. For GPU, is 35. It's much higher. 35 is much higher. So it means that the model is loaded. So those GPUs are loaded. There is a model there. There's a model that is preloaded. It means in technical terms, we say the workload, the pod is installed inside those
Hmm.
GPUs. You can think this way, but nobody's using them. Also, I'll give you a few ideas. First, because of the hype, you cannot buy GPUs on demand. There's no on-demand market. The cloud market for GPU doesn't exist. There's no elasticity. Well, when I say elasticity, it means that usually you can buy and sell within the same day, right? You buy them when you need them. This is how we learn how to use the cloud. And then once you don't need those compute, you just get rid of them because in the morning you can buy them back. We buy millions of CPUs every day and sell them at the end of the day. Exactly that. So for GPU, you can, because nobody will sell them on demand. Well, it's not entirely true. You can find sometimes on demand, but it's like a punitive rate. $70 an hour, $15 an hour. This is like 3 to 5x what it should really cost you. So the on-demand market for GPU doesn't exist. It means if you have them, you are stuck with them. But think, Murat, think that you are a bank in the US. At night, your customers are sleeping. I'm not checking my credit at 3 a.m. usually.
Hmm.
That means that at night you have very little traffic into almost everything, every application you have. And in the world, almost all applications, when they're well done, follow that pattern, the human pattern. With agents, it's slightly different, but it's still more or less low at night, high during the day. It's not a straight line. It's going to be like this, but it goes up and down within 24 hours. Well, because the GPU, you are stuck with them for 1 year or for 3 years. Even if you don't use them during the night, you still have them. So automatically the utilization cannot usually be higher than 50%.
Sure.
High during the day, low during the night. And because it's high during the day, but it goes up like this, and you need them for the peak, otherwise you have bad quality of service, you're condemned to provision for the peak and not for the low, and you cannot use them at night because most of your traffic doesn't. It's mostly true. Some companies do training at night, but very few companies do training. The business is the business of inference, not the business of training. And then also some smart company are global. So if you're the same bank, but you do have customers in Asia and in the US, and you are smart in fleet management, then you can do global load balancing of your fleet. So at night, People will use your GPUs in the US, in Asia. So, I mean, the GPUs are in Asia, in the US, but the users are in Asia. So you can do global load balancing, but there are very few companies that are truly global like this. And also, there are very few companies, I don't know any, or maybe one or two, like Samsung, that have global fleet balancing strategy because they understand what I just mentioned. Great company. So 50% is probably the highest you can think, maybe 40% is. It still doesn't explain the 5, but 50, 40 should be what good looks like on average, not 5. The reason why 5, I think, is because the act of buying the GPU is disconnected from the understanding of needing the GPU or using the GPU. In fact, remember, it's the hype. What happens when there is hype? We have the fear of missing out. It is as simple as this, Murat. You fear of miss out. Like I have a hyperscaler that came to me last week and say, hey, we have 8 B200, so that's high-end GPU. We have 8 B200 available right now, 8 nodes. Do you want them? If you ask that question to a global Fortune 500, the procurement, or maybe even the CTO, they're almost likely going to tell you, yes, I need it. Do they need it? Do they need it tomorrow? Do they really use it? Nobody knows. But they will buy them anyway. So I think the hype is kind of feeling this. It is so existential to you that you fear of missing them out that you probably will buy them.
Yeah. No, it's just literally very striking numbers. I remember, like, even when we first started talking about 5 years ago about CAS, like, we see very similar trend in utilization, right? We had a similar problem for the CPUs. Now we're seeing a mirror image of CPUs in the GPU market without the spot market, right? This is literally people contracting all these things, even if they don't have a good sense of forecasting how much they're going to use. Um, no, very, very interesting stats. I'd like to switch gears a little bit to the dollar impact of all of this, right? We talked about tokens are almost becoming a real operating metric. Like we have a term for it called token maxing. And in some of the larger enterprises, the managers use token consumption as a proxy for employee productivity. I think that kind of begs the question, do you even think companies are mature enough in terms of how they measure, forecast, or optimize this new token-driven infrastructure cost? What is lacking in the current tech stack that would enable these companies to make sure very highly automated and optimized token usage?
So I have both a message. My feedback is it's a great question, but the human cannot reply it because it's too complicated. So you need to have almost like an automatic framework that optimize your usage of tokens in this case, because the unit of tokens is impossible to understand. So automation is I think is the only option you have. But I'm going to show you a screenshot I took from a research report that was trying to estimate the value of each LLM. And not from the cost per token, but the cost of outcome. It's very hard to do, right? But it at least puts more return of investment idea. It's just not how much it costs to run, but how many of those do you need to get the same outcome? And then what's the cost at the end? And compare this with some models and do it in a way that the models the outcome is relatively similar, which is also very hard to do. So I'll show you how it looks like. And believe me, I took that screenshot 10 minutes ago, just before we started. So I can send the report to the guys that in the audience that want to see it. So they came up with this. Yeah. By the way, I'm not here to argue the position and whether this is valid or not. And you probably need a PhD to know that. But I want to show that there's no straight line, well, except one, which is minimax. So let's take Gemini 3 Flash as an example, because it's the striking one, right? So the average cost per million token is around $3.5 for that test. Let's assume it's correct. So the public price of Gemini 3 is $3.5 per million token. But if you use Gemini 3 Flash to solve or to solve a problem, then solving the problem costs you $705. So it means that, in fact, Gemini 3 is expensive at a measurement of outcome-ish.
Yeah.
But it doesn't look like it's expensive from a unit of token, but the tokens are not identical. Or, and I think it's the case here, maybe Gemini 3 produces more token than it should, and because you pay each of them, well, it produces more token in this example, and because you pay $3.5 per million, at the end you pay more. And then you have others, it's the opposite, like GPT 5.4 is more expensive than Gemini 3, but it's actually cheaper by outcome. One of my personal favorites, and I'll show you why it's one of my personal favorites, is Minimax 2.7. I'm a big fan of Minimax 3 that was released a week ago, because that's the one, that's kind of the base. That's like, yeah, I'm cheap and I'm cheap. Well, let's say I'm not too expensive per million token, and my outcome is great. And everything else is not that beautiful. And you notice Opus 4.7 is at $30 per million token. It's probably the output cost, if I would guess. It's also the most expensive to run. And it's the most popular, at least for coding agent, until 4.8 came. Because we are human, we always want to use the best one, right? And Opus is arguably the best one. And because it's the best one, that's the one you want. You know, I call it the paradox of the iPhone. Like I bought the iPhone Air, 17, but nothing was wrong with my previous iPhone, but that one is the shiny one. So of course I bought it. And I think the human developers using coding agents will want to use Opus because it's the best one. But if you are looking at the return of investment, it's questionable. I mean, in that example, it is not. I mean, it's probably still the best outcome or one of the best outcomes, but it's like 3 times more expensive than Minimax. But why do you not use Minimax? Because you don't know, because as a human, you will buy the iPhone.
Go for the best thing out there.
Yeah. So I'm going to show you one example of this. We at CAS, we use, it's called a harness. We use a multimodal harness. So we use a coding agent that select the right model for the task. So it's automatically select the model for the task. So it will use any model it feels like it, but it will use one that it knows or it feels is the best for the outcome. And I'm going to show you what happened in the last 1 month here. And it's not a screenshot anymore, it's a real number. So this is some use of model, a lot of model, 46 model. The use case is a coding agent. This is 30 days of a coding agent. By the way, the low is the weekend. For some reason, yes, we were all working last weekend. But you notice one thing. First, there are a few dominant one, like this, right? I'm sure it's Opus. I know it's Kimi. Interesting. The dominant one is Kimi, then Cloud Sonnet is yellow, is second in the list. And Minimax is third, and Opus 4.6 is number 4. Look what happened here. July 15, the blue started. June 22nd, the blue is dominant in number of token. Blue is Minimax 3. It was released the 15th of June. It became.
You're saying that this solution is automatically picking the best, model for the application.
Exactly, and that's how you do token optimization. You look at the outcome. It's impossible to calculate the return of investment, but at least you say, select the one that feels that it's the right one for the job. And don't let the human do this. In fact, the human doesn't even know. Why would they? because the outcome is what they're looking for. Integrate this into your coding agent so you don't need to specify which one should be used. We call our coding agent kimchi because it looks fun. It's spicy. It's cool. And all our developers are using kimchi coding agents instead of Claude. The coding agents still use a little bit of Claude, right? You see, yesterday, Claude Opus 4.6 is, Claude Sonnet is 7, these are requests, so 7,000 requests. So it still use a little bit of it. And a little bit of GPT and a little bit of Nemotron, which is open source from NVIDIA.
Yeah.
He went to Minimax 3.
No, very, very interesting. Very interesting. I think the way you're thinking about is the right approach. It's not always, per million token cost, which is on the face and everybody kind of anchors on. It's going to be what is the cost for each outcome, each workflow, each use case, each work that people need to do. I know we're a little bit over time, but I have two more questions that I'd like to ask you, which I love talking to you about on these topics. So the first question is, I mean, you guys develop incredible dashboards for CIOs and CTOs, and also, providing real cost savings. What do you think that currently, this is a future prediction, which I'd like to talk to you about a little bit. What are some of the like one, two, three metrics that currently people don't track, but you believe is going to be, on every CEO, CIOs or CTOs dashboard on a daily basis they're tracking?
Yeah, well, nobody is tracking what I just showed you. Consumption of token, cost of token by model, by team, by individual, understanding where they spend the money and why. Nobody is tracking it because it doesn't exist. There's no dashboard in the planet that can show in a way you can consume. Well, it can show the cost probably, but it will never tell you what the outcome should be, whether there is a return of investment. A reason why I say this, this exists almost everywhere with our users. We have a lot of users. We give them access to what I showed you, but that's not the point, right? There's no solution that exists for this, really. The reason I say this is because the outcome of that is horrible. It's called budget. So, when you cannot track something and you cannot explain the reason and you cannot understand the unit that drive the cost, which is called token, then what do you do as a CFO? You say, well, I put a red line. Above, stop. Below, okay. So what happened there is you have, it's called rationing. Murat, rationing means like this. You are a partner at a fund. So you use a laptop, it's your daily life. Imagine that I go and I say to you, Murat, hey, the battery of your laptop only lasts 1 hour and you can only charge it once a day. Sorry. Like, that's exactly what a lot of enterprises are telling right now their developers. Hey, you can use tokens, but only up to here. Sorry. So what do you do as a developer? You stop and do nothing. Like, can you imagine this? The byproduct of not understanding how much you spend and why in token is that someone is giving you a budget and you can't do above it, and you will consume it in a few hours and you do nothing the rest of the day because you can't. Of course, there will be shadow IT. You will, you'll pay $20 or $100 to Claude, do it on the side. Of course, that's why it works. But this is the issue, right? It's a real issue. And then if you think Goldman Sachs is correct, this is going to be 24 times higher within a few years' time.
Yeah. Now it's the more fun question, which I think I don't remember your answer last time, but the question is, in the next 5 years, what will be the biggest surprise in AI infra is nobody is thinking about right now, other than token optimization?
Yeah, I think we kind of see it already. So we're already talking about it. Inference is what matters. you can argue Blackwell was built on OpenAI spec and cloud spec, mostly OpenAI for training. But the real use of GPU is not training. The economic value of creation of GPU is on inference. So having specialized inference machines is probably where it's going. I can start to see some of it. I really like the TPUs. I like the TPUs. I think the one that will be able to produce the same quantity with a hardware or infra cost that would be a fraction of this is going to be the winner. It could be NVIDIA, the winner also. You know, the good thing, Murat, the only thing I know for sure is that the history is being written in front of us. And it's such a great moment to be in this industry. It reminds me, I'm old enough to remember the internet days, right? The year 2000, and say, oh my God, I don't need to go to a travel agency to buy my plane tickets. This is so cool. I can do it online. It's maybe a little bit more expensive online because it's so inefficient 25 years ago. But that was the idea, right? And we lived this. I was a young guy and I was thinking, oh my God, this is a cool industry. It was really slow to take off. The world we are living on, there's nothing slow. And we are seeing the history in front of us. I'll finish with one thing. SoftBank did our Series C, and of course with you guys. And Massa has the founder of SoftBank has a very nice phrase. He says, in the AI world, you have two options. You can swim against the current, and you may not make it, or you can swim with the current, and then you will swim faster. We have to swim with the current. Don't give a budget to your developers, because that's swimming against the current. Give a budget, but make it so high that the best developers will.
That we don't ration it.
Yeah, and if you do it this way, you swim with the current. You will swim faster than everybody else.
No, yeah.
That's
Laurent, this was great. Thank you very much for joining us. I honestly look forward to our next catch up because every time we talk, there is like a massive transformative shift in the industry. So I think next one I think is going to be a lot of fun too. And also thank you everyone for tuning in. And we're going to post the video of this conversation in the next few weeks. And if you have any questions for Laurent or the cast team, please reach out to them. They're available. Thanks, everybody. Please take a moment to review the legal disclaimer. I will leave it up for you to review. Thank you.